All right, this is section 11.2 odds. So odds and probability are definitely related, and we're going to see that with this section. But before we see that, we have to discuss what odds are. So odds can be written either as a fraction. If we write them up as a fraction, you will see the top over the bottom, obviously, or the numerator or the denominator. Or you can write them up as A colon B or A to B. So an example says 5 to 3. The next example next to that says the same thing, 5 to 3. There's two types of odds. Odds for an event occurring and odds against an event occurring. So if we say that A is the odds for an event occurring and B is odds for against an event occurring. So if we have odds for an event, it would be A to B. Odds against would be B to A. Odds against will be the probability that the event will fail over the probability that the event is a success. Now here's the deal. When you have a sample space, your failure plus your success should equal your sample space. So that's how you can check to see if your odds are correct. So once again, odds for is the probability that the event will be successful over the probability that the event will fail, or success to failure. Okay? Once again, the probability that the event is a success plus the probability that the event is a failure should equal the sample space. So let's see this in action. Let's look at the next example. It says determine the odds against rolling a 4 on a fair die. So we're basically looking at odds against. Our sample space is 6. And a die has 6 sides, 1, 2, 3, 4, 5, and 6. So we want to know the odds against rolling a 4. Well, I know the odds for rolling a 4 are 1 over 6, or it being successful is 1, because there's only one side that has a 4. And the probability that the event will not occur is 6, which is the sample space, minus the success, which is 1. So 6 minus 1 is 5, because there's 5 faces that do not have a 4. So now we have to look at the wording. The wording says odds against. So that means I want failure to success. So failure in this case was 5, because there are 5 sides that do not have a 4. And success is one side that has a 4. So it's 5 to 1. Once again, if I add 5 and 1 up, I should get my sample space, which is 6. So let's look at the next example. Determine the odds for rolling a 4 on a fair die. Well, odds for means success to failure. So there's one side that has a 4, and there's 5 sides of a dice that do not have a 4. So success would be 1 to failure, which is 5. So 1 to 5. So let's look at the next example, or the next objective rather, which is changing from odds to probability. You have to read the problem carefully. Is it odds for or odds against? Remember, odds for is set up with a formula success to failure, and odds against is failure to success. Write what your odds are in terms of success to failure. Then determine the sample space. Remember, to get your sample space from odds is you add the success plus the failure. Place the success or failure depending on the problem and the entire sample space in the denominator. So odds for would be success over the sample space, and odds against is failure over sample space. So next example says the odds against Robin being admitted to college of her choice are 9 to 2. Determine the probability that part A, Robin is admitted. Well, if Robin is admitted, that's a success. So the first line or first sentence says the odds against Robin being admitted to college of her success are 9 to 2. 9 is the failure and 2 is the success. So if she is admitted, that's a success, which is 2. And I find my sample space by adding the failure plus success. So if I add 9 and 2, I get 11. So Robin is omitted is 2 over 11. For part B, Robin is not omitted. So not omitted is a fail over the sample space. So the failure, remember, was 9. And the sample space, once again, I get by adding my failure plus success. So it's 9 plus 2, which is 11. So Robin is not omitted. The probability is 9 over 11. Let's look at the next example. A card is selected at random from a fair deck of standard cards. By the way, that just means that no one's tampered with the deck. And if it's a fair deck, it has 52 cards in it. So that's my sample space. Part A. What is the probability of selecting a black card? Well, there are 26 black cards in a deck. Because remember, we have 13 clubs and 13 spades. If you add that together, you get 26 over the sample space of 52 cards. Or if you look at it, half the deck is black. So success over the sample space. So if we reduce 26 over 52, we get 1/2. So remember, this is a probability of selecting a black card. So that's a success. So the success is 1. The sample space is 2. So what is the odds for selecting a black card? Remember, we have to have it success to failure. We have success, which is 1. To get failure, just take your sample space minus your success. So if the sample space is 2 minus success, which is 1, then it's 1. So success to failure is 1 to 1. What is the odds for selecting a black card? It's 1, which is success, to 1, which is a failure. So a really funny thing is we went to Las Vegas a while ago, and in the airport, it said the odds that you will have fun are 1 to 1. So that means, the sample space is 2. So if the odds are for you having fun, that's success to failure. So 1 for success and 1 for failure. So if you put the pieces together, the probability that you're going to have fun is 1 over 2, which is 1/2. So half the time you're going to have fun, the other half the time you're not going to have fun. So I don't think that's a very successful, marketing ploy. But who knows? Maybe the person who did it did not study odds. But anyways, if you have any questions, let me know. That's the end of this section. I know these are super short, but it's just to give you, some examples to work with when you're doing your homework. So once again, remember, odds for is success to failure. Odds against is failure to success.